For as long as we've built cities, we've had this deep-seated urge to build them higher and higher. It's this incredible race to the sky, right? It's fueled by ambition, a little bit of ego, and some absolutely mind-blowing engineering. But as we keep pushing the limits of what's even possible, a really important question comes up. Just because we can build taller, does that really mean we should?
So, take a look at this. On the left, you've got the reigning king, the Burj Khalifa in Dubai. But on the right, that's its ambitious challenger, the Jeddah Tower in Saudi Arabia. Now, this project is designed to be the very first to smash through the 1 kilometer barrier into the sky. This isn't just another tall building, it's a statement about where human ambition is headed next.
But to really get how we got here, we've got to rewind a bit. After 9/11, there was this feeling, this widespread belief that the age of the skyscraper was just over. The safety concerns, the psychological impact, it all seemed like too much. It really felt like our ambition to build high had finally hit a very real wall.
Yeah, well, that prediction could not have been more wrong. Since 2001, we have built 111 new super-tall buildings, and we're talking about structures over 300 meters high. Our ambition didn't just fade away, it totally ignited. So what on earth did we learn that allowed this crazy boom to happen?
All right, so let's start by breaking down the current champion. To understand where we're going, we first have to really get a handle on what's already been built. So, what are the secrets that let the Burj Khalifa stand so incredibly tall? At the very heart of its design is this iconic Y shape. And it's not just for looks, it is a brilliant piece of engineering. The three wings basically confuse the wind. They stop it from getting organized and forming these powerful whirlpools that could literally shake the tower apart. Pretty clever. The real secret to its height is this concept right here, the buttressed core. The easiest way to think about it is like a massive tree trunk in the center, with those three wings acting like giant roots, bracing it against all the incredible forces it has to deal with. This is the structural magic that made its staggering height possible.
And the scale of this thing it's just mind-boggling. I mean, each and every one of those glass panels weighs as much as a grand piano. The spire alone has as much steel as a naval destroyer, and its daily water use, it's more than 600 times what an average family uses. This isn't just a building, it's a vertical city, and it has all the massive resource demands to go with it. So now, let's turn our attention to the next frontier. If the Burj Khalifa was like our moonshot, then the Jeddah Tower is basically the mission to Mars. It's designed to completely shatter that 1 kilometer ceiling, and that introduces a whole new world of problems. This chart really puts the challenge into perspective. We are not talking about a small incremental jump here. The Jeddah Tower is aiming to be almost 200 meters taller than the Burj Khalifa. The highest floor people can actually be on will be 80 meters higher. It's just a monumental leap. Okay, but before you can even dream of building that high, you have to solve one massive, fundamental problem. With a normal steel cable, a 1 kilometer long elevator ride is literally impossible. The cable itself would get so heavy that it would just snap under its own weight, and that's before you even attach a car to it. So, how they solve it? With this is a total game changer, and it's called Ultra Rope. It's a carbon fiber core cable, so it's incredibly strong, but it's just a fraction of the weight of steel. This single innovation in materials is what finally unlocked the potential for kilometer-high buildings. But of course, the elevator was just one piece of a giant puzzle. At these new heights, you're dealing with some really extreme physics. You've got something called the stack effect, where the huge temperature difference between the bottom and the top of the tower creates these powerful winds inside the building. Or windage, where the elevator car acts like a giant piston in the shaft, making huge pressure changes. The engineering challenges are just on another level. And all of this engineering genius brings us to the most important part of our story. We've proven we have the brains to build this high, but this is the point where we pivot from how we can do it to whether or not we should. So, is the super tall skyscraper this shining icon of sustainable, dense cities, or is it just a colossal monument to inefficiency? This is the central question facing the future of pretty much all of our cities. So to get a real answer, some researchers did something fascinating. They modeled 9 completely different ways to house 2,000 families, everything from a single massive super tall tower, all the way down to a sprawling suburban neighborhood of single-family homes. And at first, the results they look exactly like you'd probably expect. Take a look at that bar on the far left. That's the Supertall. Its total energy demand is just colossal. It completely dwarfs the others. And that makes sense, right? That's the cost of running massive elevators, pumping water a kilometer into the sky, and powering huge common areas 24/7.
But here's where it gets complicated. When you look at the energy use per square meter, the Supertall actually does better than a 16-story building. So that tells us the relationship between height and efficiency isn't just a simple straight line. But while energy is important, the most critical factor is something else entirely.
And this right here reveals the real game changer: land use. If you look at the chart, you can just see the amount of land required plummeting as the buildings get taller. In fact, the suburban community on the far right requires a staggering 110 times more land to house the exact same number of people. That kind of sprawl has a massive hidden cost. And as we're about to see what you can do with all that saved land, it changes the entire equation.
Okay, this is the key takeaway. This chart shows the total carbon footprint over 20 years. It includes the carbon cost of the building materials and the energy to run the place, but, and this is crucial, it also subtracts the carbon savings you'd get from putting solar panels on all that land you saved. And when you factor all of that in, a surprising winner emerges.
And here it is. The most sustainable model for how we live in cities isn't the Supertall skyscraper, and it's not the sprawling suburban house. It's the dense 34 to 58-story high-rise, right there in the middle. This is the sweet spot that perfectly balances the inefficiencies of going super high against the massive land consumption of spreading way out.
This really changes how we should be thinking about the future of our cities. The race to the sky isn't just about being the tallest anymore. It's about being the smartest. And you know what? The industry is recognizing this shift. The leading authority on this stuff, once called the Council on Tall Buildings and Urban Habitat, has recently rebranded itself. It's now the Council on Vertical Urbanism. And their new mission? To steward responsible density. The whole focus has changed from just height to the overall health of our cities. So, as our global population barrels toward 11 billion people, we know our cities have to grow. The choice isn't if we build up, it's how we do it. So, will we keep chasing records just for the sake of being the tallest? Or will we finally start building the smart, responsible, and truly sustainable cities that our future demands?